Good evening, children. Today we are going to start with the next part of the periodic table chapter, that is your metallic character. According to this topic itself, you can come to know that we are talking about metals. Children, in this, the metals have the tendency to lose their valence electrons and form positive ions. Now, what type of positive ions they will form? That is your cation. I have mentioned example here. Let us consider sodium atom. Its atomic number is 11. And its electronic configuration is 281. Now, this sodium atom will lose this one electron present in the outermost shell and hence get converted to sodium ion with the electronic configuration 28. Now, this sodium ion is a positively charged ion and it is known as cation. Now, this metallic character depends on further two factors. One is atomic size and the other is nuclear charge. Now, how does the atomic size affects metallic character? Greater the atomic size, farthest is the outermost shell. Hence, lesser will be the nuclear pull or nuclear attraction exerted on the electrons of the outermost shell. So, hence, it will be very easy to remove the electrons. Are you getting? Let us take example of potassium. Say potassium has atomic number 19. Its atomic number is 19 and its electronic configuration is 2, 8, 8, 1. Now children, this one electron is present in its N shell. This N shell is far away from the nucleus. Because atomic size is greater, you can see the size from the nucleus. From the nucleus, first shell is your K shell, then next shell is L, then M and then N shell. Hence what happened, this N shell is far away from the nucleus. So this one electron present in this N shell experiences less attraction. Hence this one electron can be lost very easily. So now this potassium will tend to lose this one electron and get converted into potassium ion. Initially the electronic configuration is 2881. Now the electronic configuration after the loss of one electron is 288. This is the nearest noble gas configuration. And this ion is a positively charged ion which is known as your cation. So hence we say that as the atomic size increases, the attraction of the nucleus towards the outermost electron is less and hence the electron gets removed very easily. The next factor on which this metallic character depends is the nuclear charge. Greater the nuclear charge, greater is the force exerted by the nucleus on the electrons of the outermost shell. Hence, these electrons it will be very difficult to remove the electrons from the outermost shell. Let us consider, say, one example is across the period. Let us consider lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon and so on. Now, we have studied already that across the period atomic size decreases and nuclear charge increases across the period. Now, let us consider for say carbon. Okay, carbon. Let us consider carbon. Carbon has the atomic number is 6. Electronic configuration is 2, 4. Now, the size is very small. These 4 electrons are experiencing greater nuclear attraction. Hence, it is very difficult to remove these electrons. So, greater the nuclear charge, greater is the attraction, difficulty is in removal of electrons. Are you getting, children? Now, we need to remember that metals are good reducing agents. Children, this I am going to explain here again. Let us see. Remember, metals, they tend to lose electrons and they gain positive charge on them, known as cations. Are you getting? Now, in the previous classes, we have done oxidation and reduction. What is oxidation? Oxidation is loss of electron. Loss of electron. That means if the metal is tending to lose electron, it undergoes what type of process? It undergoes oxidation process. So those elements which undergo oxidation, they act as reducing agents. Hence we say that metals are good reducing agents because they can easily lose electrons. Hence I have mentioned here metals are good reducing agents. Now what are the trends in the metallic character? When we go down the group, the metallic character increases and across the period metallic character decreases. Now children, we have to understand this concept also. Let us see here what is the reason. The reason for the trend. Down the group, what happens? The atomic size increases down the group. Nuclear charge also increases down the group. But we have already studied, increase in the nuclear charge is overcome or it is dominated by the atomic size. Hence outermost electrons experiences less inward pull. That is, they can lose the electron easily. I have taken one example of group 1 elements. Group 1 elements is your lithium, sodium, potassium, rubidium, cesium and francium. Now as we go down the group, let us see here lithium, sodium and potassium. Atomic number for lithium is 3, sodium is 11 and potassium is 19. Electronic configuration of lithium is 2, 1. Sodium is 2, 8, 1 and for potassium it is 2, 8, 8, 1. Now as we go down the group, number of shells you can see is increasing. Lithium has 2 shells, sodium has 3 and potassium has 4 shells. So the nuclear attraction of the electron with potassium element, okay, the electron of the potassium which is present in the outermost shell will experiences less attraction as compared to lithium, because L shell is near to the nucleus whereas N shell is far away from the nucleus. Here lithium has Kl, sodium has KLm N shell, potassium has K, L, M and N shell. So when we compare lithium and potassium, lithium has 1 electron in N shell which is near to the nucleus and potassium has 1 electron in the N shell which is far away from the nucleus. So the order of loss of electron is this way. That means potassium will lose electron more easily as compared to sodium, as compared to lithium. So hence I have mentioned here, lithium is least metallic, whereas we will not consider francium here. Francium is actually a radioactive element. We will consider cesium. Cesium is the most metallic element. Are you getting? Out of the 118 elements in the periodic table, we have cesium which is the most metallic element. Are you getting? Now let us see the trend across the period. Now across the period, whenever we consider any period, we have observed that the number of shells remains same. Atomic size across the period decreases, hence the electrons will experiences more pull towards the nucleus. Hence what will happen? The tendency to lose the electron will be difficult, hence they will not be considered as metals. So when we move across the period, I have taken one example of period 2. lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So across the period, what do we observe here is metallic character decreases, because across the period nuclear pull increases due to the increase in atomic number, and here you can add that atomic size decreases across the period. Atomic size decreases across the period, hence it cannot lose the electron easily. So hence we will see that across the period lithium is most metallic, whereas neon is least metallic. So I have mentioned here lithium and beryllium shows metal tendency. Boron is a metalloid. Metalloid means it has both the tendencies, the property of metal as well as a non-metal. Whereas from carbon to fluorine or neon is a noble gas element. So carbon to fluorine, these are non-metals. I hope that you all have understood. If you all have any query, then please put up your question. Thank you.